Hey guys, good evening. I hope I'm pretty much audible. Just do let me know if my screen is visible and I'm audible to you also. Looks like it's fine. But if any case if I'm not audible, just to ping in the chat. So we'll try to fix that. But again, I welcome everyone whosoever is part of our chat today. So we'll be continuing to what we discussed yesterday. So we'll be talking about the things on the live demo on NLP. So we did a lot of interesting things yesterday, right? So we took up the data and then we started solving the data as it comes. So and in fact, we did implement a lot of things, whatever we have learned as part of the concepts in the data, what we had yesterday, right? So you remember, so we discussed about all the concepts till date, like talking about your NLP techniques of tokens, and then we discussed some of the back of words. We discussed about the word cloud. We did a lot of analysis. I wouldn't say a lot. I would say we did some basic analysis of my data, and then we also talked about the visualizations. We did some interesting visualization on top of our existing data also, right? But again, so that's been it. So we did not complete the entire demo yesterday. So let me just quickly finish the remaining part of our demo, and we'll do that today. But again, if anybody has any questions from whatsoever we have discussed so far, please do put up in the chat. So I'll try to answer your queries to the best of my knowledge. And still, if there is anything which you want me to cover, so just to let me know in the chat. So we'll take that, right? And again, as always, I'm monitoring my chat, guys. So if anybody has any concerns, any doubt over whatever we have discussed so far, just do let me know. So we'll take that, right? As always, before proceeding, let's have a quick round of introduction. So you know, my name is Arpit Jain, and I am a senior data scientist myself. I have almost 9 years of industry experience, that being into multiple domains. So uh, I've been part of finance domain, manufacturing, automobile, and also in telecommunication. So I've seen the data, I've seen the industry. So if any concerns regarding those industries, also you can put up your questions. Along with that, I'm also a motivational speaker. So I take up industry sessions. I talk to students regarding their job, regarding career. So anything regarding in that area. So you can always ping me with your queries. So we can always take them. And also, as part of our subjects in the agenda, we'll be talking about Python SQL data science. So Python we started, I think, a couple of months back, more than a couple of months back. We did cover a lot of good things there, but now we are into the problem solving part. So we are doing the competitive programming questions from lead code, from HackerRank and all that, right? So we are doing those. Also in the sequel, we finished the conceptual parts that is required for your interview purposes. We did that, but now again, it's all about practicing the questions, right? So we are practicing the questions from again these competitive websites, LeetCode, HackerRank. So that's what we're doing in SQL also. Along with that, we are into data science. Along with that, so data science, we did finish visualization. So now we are into NLP. So I think we'll be done with our NLP techniques demo today, and then maybe we can extend it further to some other things. So we have the live chatbots, and also we can take it as it comes, right? But before proceeding, guys, you know there's a mandatory promotion. So you have the code right in front of your screen, which is Python 10, right? So if you use the Python 10, you always know you're gonna get a free bonus Relevel sample test paper, right? So guys, please bear with me. So it's a mandatory promotion. So many a times candidates do miss out on the great opportunities due to multiple reasons, and it could be like they don't have a better degree, or they might be having a poor networking, right? So by better degree, I mean not having a degree from a tier A universities. Also, poor networking, that means that you don't know the right set of people to ask for referrals, right? So that becomes sometimes very important. And also the resumes with which you're applying, so it's not really standing out from the crowd. So because at least there are 100 other applicants for the same job, right? So there might be something missing in your resume, or there might be something which is totally beyond your control, right? So there could be anything in that per se. So could be one of the reasons which because of which you might be missing out on the great opportunities. Also, You're applying to n number of jobs, like 50, 60, maybe even 100, more than 100 jobs, still you're not getting even a single interview call, right? So very practical problem. Yeah, everybody faces, I would say most of the people faces that. And to cater these issues only, so Relevel has been introduced by Unacademy, which is India's first test hiring platform by Unacademy, which is helping you in turn to get your dream job, right? So here you are purely dependent on your skills and talent, and nothing on your degree or any sort of people networking, right? So it's purely on your skills and knowledge. So basically, if you're knowledgeable enough, you will be getting your job here, right? So how does it work? So it's more of a testing platform. So you'll be asked to go through an assessment, so like a test, right? And I mean, depending on the area of interest you are part of. And then on that assessment platform, the only expectation from you will be to get the best score out of that platform, right? So like if you are able to get the best score, so based on your score only, you will be actually getting the interview calls. The companies will be reaching to you directly. So basically, it's if you're skilled enough, if you're knowledgeable enough, you should be able to get the good score. And if you're able to get the score, a good score, that internally will push you for the calls from the company. So that's how simple it is, right? Along with this, there are certain other benefits also if you participate in the testing platform, like at least 50 plus companies, including the top startups and the unicorns, they are hiring directly from the Relevel platform. And those include ENY, Upgrad, Cred, Razorpay, Urban Company, and many more. So they are hiring directly from the platform Relevel. Also, there are at least 100 plus open job positions right now across 3 different portfolios. That includes business development, front end, and the back end development. Multiple sub roles available within these portfolios. You can always choose depending on your requirement, on your area of interest. And also the part here is completely online, guys. So you can take this from the comfort of your home. So you're not supposed to be physically present anywhere to attempt this test. You can take this from the comfort of your home. And also, this is completely free, guys. So you're not expected to pay even a single penny to be part of this test. So you can actually give this test for free. The only expectation here would be to actually finish the entire test in a single day. So it's an assessment, right? So there are multiple rounds in the assessment. So the only expectation from you is to finish all the rounds in a single day. And that day could be of your choice, right? So you can always book a slot. That date could be of your choice. And the Relevel scores are generally revealed in a week's time, right? So that's how it is. And since it's an assessment, right? So it's they're also a qualifying score. So now you're expected to get at least 70% marks to make your Relevel profile. But in any unfortunate situation, if you're unable to get that score, you can always reattempt the test. But that can happen only after 30 days of your first attempt, right? So be watchful of that. And again, there are certain other goodies involved. So if you participate in the Relevel testing platform and you are one of the top scorers in a particular category in a month, you will be awarded with some exciting goodies like MacBook, iPhone, and all that. So again, a charm for you, right? So with this Relevel, guys, you are in a unique position to invite interest from the companies instead of you hunting for your own opportunities, right? So it's like once you have given the test, you can always just sit back and relax. The companies will start reaching out to you based on your Relevel score, right? Also, the registration is also quite easy on the Relevel. So the link is there in the description. So just go through that link. And once you select that link, the first thing they'll ask you to choose the test of your choice. So there are 3 portfolios right now: the business development, front end, and the back end development. As I said, multiple roles like the sales associate, relationship manager in the business development, front end engineer, data developer, Angular developer, web developer in front end, and the back end engineer, data engineer, and all that in the back end development. So depending on your area of interest, you can always choose the test which you want to be part of, right? And the next would be to choose the test date, right? So test date here, the slots are limited because it's a beta platform anyway. So I would request you to book your slots fast. So once you have chosen the date of your choice, the last would be to fill up your demographics, like the full name, email ID, birth year, current state, along with your gender. And at the last, you have an option of the promo code. So where you can just put in the code Python 10. If you're going to use the code Python 10, you're going to get a bonus free Relevel sample test paper, right? So do not forget to use the code Python 10 here, guys. So if you have used the code Python 10, so this is how your dashboard should look like. So you have a practice tab on the dashboard screen. You can see that. So that where you have the option of the sample test paper. So if you have used the code Python, then this should be enabled for you. And you can see an option of download this. You can always download the test and be part of this test. So you can always be prepared before the actual test, right? So that's how simple it is. So registration is also quite easy. You've seen that. So guys, do register for the Relevel today. It's anyway free of cost. The link is there in the description. So you're not paying a single penny. So it's anyway free, right? So there's no loss for you. If you participate in this, definitely I believe it's a beta platform. So this is the right time to participate in this, right? So you can try it for once. If you feel that you're not getting benefited, you can always take your decisions elsewise later, right? So do try it for once. Also, we have an official Telegram channel also, so do join that channel. So this is a one place top for you for all of your queries or upcoming schedules and all that. So do join this channel. So you will be actually getting all the live updates for your schedules and all that. So with this, guys, I would request you to do like and share the video. So if you feel that you're getting benefited, do like and share the video. Right, so with this, guys, we are into our demo. So we'll be talking about our NLP Live Demo. So we'll be taking care of the data set, which the way we were taking it yesterday, and then we'll try to finish up the remaining things, and maybe we'll build up an ML model also on top of that. Cool. So with this, let me jump quickly to my demo part. Let me just capture the screen. Right, I hope my screen is visible to you all. Right, so yeah. Cool. So I'm just going to give you a quick refresher of what we discussed yesterday. So this is how we started. There are a set of certain very interesting group of libraries which we generally import, right? So I have subdivided into 4 different modules, sub-modules, like for example, for data analysis libraries like NumPy, Panda, String, OS. And then in the visualization, so we do the visualization also, right? So we have Seaborn, Matplotlib and all that. Then NLP modules for NLTKs like STEM, Corpus and all that. So I've imported that also. And then at the last, we have for ML models also. So for MLs, just imported the train test bit for now, but we'll try to import more once we actually start building up the models and all that, right? So that's how we started. Again, the process remains the same. You have seen that. So we have the raw text. We're going to tokenize it first. That's a very first step. Text cleaning. So all my text cleaning step will be here. I'm preparing my data for the model. And then at last, I'm going to vectorize it. So convert the text to my numbers. And then I'm going to put up the ML algorithm model to classify the spam filters and all that. So I'm going to create that model for me. Right. So we loaded up the data using the basic mechanism of pandas, read CSV, the module here. And I've just given the path, and then I've just used loaded up the data, which is already there in my local. So this is how the data was, V1 and V2, and certain unnecessary columns were there. So what we did, so we just kind of dropped the data which was not needed, because we figured out that almost 99% of the data were missing from these columns, right? So we dropped it. And then we had 2 columns left, V1 and V2. So this seemed like this more of a label. Here's ham and spam. So ham normal, spam like spam messages. Then I have the actual message here, right? So this is how it is. So we just renamed it to label and message. So now it is more I would say user friendly kind of a data now. Then we started with some EDA. So we did EDA on this. So we figured out that there are 2 classes, ham and spam. And then the ham is almost say 85% of the data is towards my ham. And then spam is roughly 15% of data. And then we also saw the top variables. So top is like, sorry, I'll call you later. It was repeated 30 times the maximum in ham, and likewise for others, right? So we did see that. And then in the analysis, see again, analysis is like without boundaries, right? So you can do analysis in any direction. It's purely your intuition, your way how you can think about the data, right? So we just extracted one feature set here. So we created a feature length. So basically counting the number of characters we have in the messages, right? So that's what we did here. And then we have the lengths of all the messages captured. And once we saw the length card description, basically, so we, for my ham and spam respectively. So we saw that we have the minimum and the maximums here. So you can see the maximum was 910, which is quite high in the normal message. And this is how the distributions are, right? So we saw that generally the spam messages are longer. So we saw that here. So the mean is 71 and the mean for spam is 138, almost a double. So we saw that the spam messages are generally longer, right? So this is some kind of interesting inferences we got from this. Right. Okay. Hey Arpit, how are you? I'm good. I'm good, HK. Thank you so much for asking. I hope you're doing good too. And thank you for joining us. Cool. So coming back again. So yeah, we did these kind of basic analysis, and then we jumped into visualization. So we plotted one basic pie chart where we had the distribution of my ham and the spams, and we saw that almost 86% data was towards my ham, and spam was almost 14%. So that's the basic thing we plotted. And then we also saw the distribution of my lens. So we saw that the frequency distribution of how it looks like. So we have the bigger bars on below 200. So after 200, like almost negligible bars we have in terms of frequencies. So that's how my distribution of my lens look like. So we did that also. And we also saw what was that 910 characters, the maximum characters. It looks like some kind of a heartfelt message from someone. So that was it, right? And then we also saw the distribution of my the lens basically across the different sections. So across my labels of ham and spam. So how my distribution look like. So also we saw that. And then we actually jump into the text processing post this. So post the basic data analysis and the visualization. So here we developed a function basically where we were doing two things. We were checking for the punctuations and also we were checking for the stop words, right? So we did two things here. So we created a function to remove the punctuations and also to remove the stop words. So we just added two basic commands here. So we did write this. So for the no punctuation, I used the punctuation module from string. So I just removed it from my entire characters and the entire messages. And then at the last we removed the so basically the stop words. So stop words we use the English stop words, and then that's basically my custom. So I did not customize this stop words list. I can always do that. So we can always extend this to any need whatever we have, and then we can always do that, right? And then post this, we did analyze our data in terms of word clouds, and then we saw for the spam, basically we have the major words like free, call, text, txt, customer service, claim, new, reply, and all that. So these are my very prominent words on the spam. So the word cloud of spam was actually quite decent, and it is making sense also because free and all that. So that's basically an identifier for my spam, right? And we saw some of the interesting words for the spam. We saw that, and likewise we created it for ham also. So it's pretty much okay. So got, go, come, no, okay, time, love, and all that. So this is coming from my ham perspective. So one of the interesting features, interesting words coming from my normal messages. So we also saw that, right? So this is what we did till now, and where I believe now we are actually talking about my transformation of my original data set, right? So now this is where we will be doing the actual transformations, right? So where uh, we will be talking about the model building processes and all that. Cool. So quick gist of what we did yesterday. So let me just keep on running the scripts because this is a stale file now. So I would have to run the files again. Just bear with me for this. If anybody has any questions so far, just please do let me know so we can take up those meanwhile. I hope I'm making sense, right? So this is again a very simple process, guys. So here I'm actually not doing anything fancy, to be honest. Okay, so this is basically my actual way of performing the thing. So whenever we do anything, right, so the standard process always remains the same. So there are certain set of things which we always do, but again, the direction of your analysis, like EDA of your visualization, it can go in any direction. So I just did a very basic analysis. I just showed you what things what I'm thinking in that direction, right? But again, it's not like that's the only way where you can actually, apply your logics. So that's not exactly what I meant, right? So I hope that is basically making sense to you. Cool, so we did the visualization, that is fine, so we're not going to do that again, so we have already seen that. So now from the stop words perspective, we have created this function, and then we have the messages and all that, so that's fine. So I have my spam words is also done, and then I have my ham words. I'm going to process the ham words also, so I'm not going to call this word cloud function again. So I'm going to just apply the preprocessed text function on my entire data set. So that might take, I think, some time. I think maybe a minute or two to give the results. But again, if anybody has any concerns, maybe I'll just stop this. So this might not be required actually. So I'll just stop this. So, and then this is also not required. I'll just call it over my entire message only directly. Cool. So meanwhile, this is running. Anybody has any questions from whatsoever we have discussed so far? So this is where now my actual transformations are happening, right? So I have my data now, right? So now on this data, we are trying to remove or perform the actual, what to say, uh, the actual processing which we want to do in the entire data set. Because now we are looking about, we are actually trying to solve the question, right? So we are trying to actually trying to build up a model. So where I have all the set of tokens available, the data is cleaned, and now I have the set of vectorization being done. So basically at the end, we'll be converting the text into the numbers, right? So that's where my vectorization will also come. So I'm going to list down certain steps post this, right? So we have already done the textual, my pre-text analysis. So now post this, we'll be talking about the vectorizations, right? So vectorizations may we'll be trying both. So we'll be trying my count vectorizer, and also we'll be doing the TF IDF vectorizer. So we have already seen these two, right? And then once we have the data, we're going to transform the data, right? So transform the data to create bag of words basically, right? So basically from this we'll be creating the bag of words, which will be my actual the columns. Now once the bag of words are created, now my data set is prepared. So that is my final data set. So this is actually gonna be my final data set, right? So now on this final data set, I'm gonna apply the machine learning model. So that's where my machine learning model will be applied. Okay, so that's what we're going to do. And then now once we have the model, we're going to evaluate the model also, right? So evaluate model based on performance. Cool. So that's basically that's what follows post test. So once we have analyzed the data, once we have created the data, so now we are eventually in the process of building up the ML model. So where the kind of application is built, or what to say, a module is built, where you can just call up that model, right? And then you can pass the original message, and then the machine, the model will actually tell you whether that message is a spam or ham, right? So we can build up that model on top of that. So that's what we're going to look at that post my bag of words creation. So meanwhile, this is getting pre-processed. Yeah, so because that will take time, because we are doing 2-3 things here, right? So and it's a text process. So text processes are generally time consuming, because it does a pattern identification and for each and every word. So it's actually time consuming. So it might take maybe a minute or two. So we can wait for that. Meanwhile, guys, I hope count vectorizer, IDF vectorizer, anybody and nobody has any concerns in this, right? So we already discussed about this. So we have a question here from Hemant. Is count vectorizer take word frequency? Yes, Hemant, absolutely correct. So count vector, in fact, both of these take word frequency, but in some other logics. So we discussed about that in the previous session. So count vectorizer basically talking about my number of occurrences of my each tokens, right? So basically, how many times each of word has happened. So I mean, there's a logic for that. So we're gonna do 0 ones on top of that. So basically, if the word has occurred, so that's gonna be marked as 1 on all the columns, right? So and here the document will be my individual messages, right? So wherever each word of my document has occurred, so that will be marked as 1 in the column set, and that's how the count vectorizer works. So basically, counting the number of occurrences of my each word. So that's a plain simple logic of count vectorizer. where TF-IDF is more of an advanced one, where we are penalizing the most occurred text in the entire document set, right? So, if, for example, suppose the words like say is, am, are, and all that. So, or the words which are getting repeated multiple times in certain documents, in all the documents, whatever we have from the corpus, right? So that will be penalized, and you will get the lesser scoring for those terms which are occurring more, and you'll get more priority to the ones which are occurring less. So we have a log transformation which is happening on top of my the words. So the log multiplier of my words. So that's how my TF-IDF works. So it penalizes the words which are occurring more number of times. So that's basically how TF-IDF works. Cool. But again, it does not mean that TF-IDF always works better than count. Yeah, but in the most of the scenario, TF-IDF does work better than count vectorizer. But again, it's not like count does not give you a model performance. So again, in the data science arena, it's more like there are multiple options available. So again, these two are not the only two vectorizers. There's something called hash vectorizer also. So there are certain other vectorizers as well, right? So which is converting, which is some sort of logic to convert your actual strings or a text to numbers, right? So some sort of logics. So count has another logic, vectorizer, a TF-IDF has another logic. Likewise, hash will be having some other logic, some other more, right? So it's all about understanding the pros and cons of these vectorizers and how they fit into your data, right? So that's how we check it. Cool. Uh, any other questions, guys? I hope I made sense, Hemant, right? It's taking, I think, more time. Okay, this is really, I think, I don't know why it's stuck. This is where the problem is in the live demo, so you have to wait for the results actually. So let's wait for a minute maybe, so this will get processed. So let's wait for a minute. Meanwhile, let's check some other topics. Okay, so let's talk about our EDA maybe. So, I mean, do you guys have any other understandings of how we can proceed it? So, apart from what we have discussed here about finding out the length of my messages, right? Do you think of something else? Can you think of something else which you can do on top of this? Because as I said, my analysis is it's more of an endless boundary kind of a thing, right? So analysis is not like what I've done here. That's the only thing which you can perform, right? You can actually do anything on top of this howsoever you think that data is actually good. So do you think anything which might make sense here? Any logical understanding? I was maybe thinking to add a column where we can actually, take instead of length of my characters, I can do a word count also, right? So maybe I can just simply add another column where instead of length, I can add a column of word counts. So the number of words, and in fact, the number of words where the characters of each word is more than two, right? So because the smaller words I'm gonna anyway remove later. So I'm gonna have the columns for larger words, maybe say more than 5 characters, right? So this is again, maybe we can try to see the interaction between, yeah, word count definitely human, so we can do that. So again, it's all about your perception. Again, as I said, so there is no limit to anything here. So you can always apply your own brains and try to extract as much information as you can from the available data you have. So text are generally a bit of a tricky data set. So you can always think of the way you want to implement it, right? So if there would have been some columns such as say time and all that, right? So suppose this message was sent on some time. So and suppose if there would have been a column where you have the timings of your messages also, right? So that would have been a very interesting column. So if the data, if the date time column is there, so we can extract lot many things from there. So we can extract the time of the day, right? So at which time is being sent, so like the daytime and the night times. And then we can check for the weekday, weekends also. And then we can check for the days, we can check for the months, like years is like irrelevant, but I'd say maybe months, maybe, February months might be having larger set of, lovey-dovey messages and all that. So yeah, so some set of correlations, maybe higher messages in the month, more length of messages, length will be higher in the month of February, right? So might be. So some sort of things which you can always extract from date. So always remember, guys, so if your data set has date column or a date time column, I have seen this tendency that people try to skip out this date time column and they try to focus on the available numbers or the text, whatever they have, right? So always have a tendency to actually use the date time column. So date time generally I've observed that has very, very, very fruitful informations, right? So you can extract date time into like 10 more other columns, right? At least 10 more. I can give you at least 10 more. You can always do that, right? So that actually those are your feature sets, right? So that can actually help. So always have a tendency to use your date time columns to the max you can, right? Right, yes, maybe we can count the spam words in a message. Yes, absolutely. So maybe if we have the word, so in the words also we can have the distinction between my spam and the ham, and then we can use that feature set, basically my spam messages, the length of my spam messages, and then from the word list as part of a feature set for the model. So yes, absolutely, we can do that. I meant absolutely, why not? So that is pretty much doable. So again, as I said, so this is like a never ending thing, right? So data analysis might be of say 10 minutes, might be of say 1 hour, or it could go even to 10 days, right? So depending on your actual logical understanding of the data. So how deep can you go in this, right? So it's purely your understanding. So it's where a data scientist knowledge comes into picture. So that's what machine cannot do for you, right? So that's what it is. And then again, the same thing in the visualization also. I just plotted two basic graphs here, right? So I just plotted a pie chart and I just plotted a histogram. So basically my frequency plot, right? I can go in any direction. So I can just keep on comparing. So as Hemant has mentioned about comparing my spam words and the ham words, right? So I can just keep on plotting like a scatter plot on the number of words and the number of say characters I have, right? So against my X and Y's, which could be my spam words on the ham words. It's totally possible. So again, I can still think of 3 to 4 plots which I can just straight away plot, right? So again, if you have any comments on that, just try to think of that. So because again, the whole problem statement here is about how you think of a problem, right? If you are able to think about your problem, that's where the solution is. Cool. So that's where the solution is. I hope I'm making sense, guys. Right, so I hope this might be done. Let's see. Still processing. Okay, that's interesting. This is taking time. Okay, so meanwhile, let's do one thing. let's try to add up our codes, right? So why to waste time? So let's try to add up codes and then maybe let's be ready with the codes, right? So okay, so vectorization में count vectorizer कैसे आप करते हो? So where exactly you have your count vectorizer, right? So you have to do the count vectorizer now, right? So count vectorizer में so I'm just gonna pull all of these things one by one, okay? So let's call it separately. So I'm gonna do count vectorizer. So I think I've already imported count vectorizer module. Looks like I must have. Let me check. Yeah, so I've already imported the count vectorizer module, right? So I'm just gonna copy this and just I'm gonna meanwhile the code is running, so I'm just gonna prepare my code. Okay, let's do that. So now I'm going to import my count vectorizer. So I'm going to call this count vectorizer into a function called as a vectorizer. Okay, so vectorizer is my function. I'm going to call it. So this is going to be my function. So whenever I'm going to call a count vectorizer, basically I'll be calling a vectorizer. I've just created the dummy name for this for the calling purpose, right? So now basically this is where I'm going to fit the actual messages, right? So on the list of words which I have, which is actually being done on top of my count vectorizer, I'm going to fit the messages. So this is where my fitting would come. So I'm going to create the bag of words. So basically my the actual list of words coming from my vectorizer, right? So I'm going to just create say bag of words. So bag of words say count, or say just do vectorizer, right? So vectorizer, right? So bag of words vectorizer I'm going to create on my vectorizer. So I'm going to call this vectorizer. I'm going to fit it on top of my messages I have. So vectorizer dot fit, and fit basically my data set which I have. So this is where my data is, right? So this is where my text is. So this is where I'm gonna call my fit module. Cool. So I'm gonna call my fit on top of my messages. So now with this, I'm gonna create the bag of words, right? So you can see I'm gonna have the bag of words here. You can always check your length of your bag of words. You can always check print some of the bag of words and all that. So I'm just going to print for now. Say for example, how many bag of words got created. So print, for example, I'm going to print the total of say print uh, total, what's it, total number of words. So I'm gonna call the total number of words, where I'm gonna call it the length of my vectorizer. So basically here I'm gonna call the length of my what? So I'm gonna call the vectorizer. How can I call it? So vectorizer dot. I think okay. So it should be vocab words basically. So here it should be length vectorizer. So this is gonna be my vectorizer. So vectorizer dot, I'm gonna call, I think it should be vocabulary, but we'll check. So I think vocabulary or vocabulary underscores, I don't remember the exact function name, so we can always check this. So I'm just gonna, so this is a very simple commands, guys. So again, it's very simple commands. So I'm gonna call the count vectorizer. Now I've fit this on the count vectorizer. Now I've created the vocabulary list. So I'm just gonna check how many words got created here. Very simple. So I'm not doing anything very fancy in this, right? Cool. So now on this, we can just keep on talking about my each of the individual matrices. So now on this transformer, right? So so basically my actual transformers, I'm gonna call my individual messages. So here this is my bag of words vectorizer, right? So bag of words vectorizer, this is where I'm gonna pass on my messages. So for each of my messages, so suppose I'm gonna now on top of this, I'll be checking some of my messages. For example, what we can just take some messages. So I have data set here. So set. So I'm going for my message. So I'm gonna call my message here. So messages, for example, so I'm gonna call my say fifth message. So I'm gonna call fourth message. So here I'm gonna just call my fourth message, and I'm gonna transform it on top of my. So I'm gonna call my message fifth on top of my this, and now we can actually see the conversion. So in terms of zeros and ones, right? So ultimately the objective here is to convert the things into zeros and one, right? So this is where I'm gonna actually pass my transformer. Now I can do this. So bag of words for 5, that could be what? So here I'm gonna call my bag of word vectorizer, and on this vectorizer I'm now gonna transform my message. So I'm gonna transform what? Transform my actual message 5 on top, right? So I'm gonna call message 5. So now if I'm gonna call my message 5 on top of this, so this is where I'll be getting my actual bag of words. So basically my zeros and ones. So if I'm gonna just print this, I'm gonna print my bag of words 5. You're gonna this is where you're gonna see the zeros and ones, right? So this is where you're gonna see the zeros and ones. I'll be showing it to you anyway. And what all you can always check the shape also of this. So if you just do bag of words here and just put the shapes, you're gonna see the shape of your bag of words, which should be mimicking your actual word length, right? So for word length, it should be mimicking a word length. Cool. So that's gonna be implementation for my count vectorizer. So we have done that. So we have checked it for the data. Now we can actually just transform on my entire messages, right? So this is what I did for my one of the data set just to check. So this for my checking purpose, right? So I'm gonna do that, and now I'm gonna transform the data totally, right? So I'm gonna put entire thing. So transform the data frame, right? So again, ultimately I have to transform the data frame. I'm not going to transform only the message, right? So now in this case, what can I do? Case here for the entire message, so message, I would say bag of words would be what? So message bag of words. Here I'm gonna transformer basically this. So bag of vectorizer. Here in this, I'm gonna call bag of vectorizer. And this bag of vectorizer, I'm going to transform the entire data set. So instead of calling my one single message, I'm going to call it over data set of my entire messages, right? So this is where you're going to get the sparse matrix. You're going to get the actual list of your columns which you have for your bag of words. So this is where you'll be getting the transformation of data frames. Cool. Now you can always check the shape and all that. So so where you'll be getting the shape of a sparse matrix. So here you can always check the shape again. So print say shape of my sparse matrix. Right. So I think I missed spelling here. Sparse matrix, and here the shape would be what? So shape would be my just message shape. So it'll be like message underscore bag of words dot shape. Cool. So this is gonna give you the actual shape of my bag of words for the messages. So this is where I'm gonna transform my data into count vectorizer, right? So this is how I'm gonna do the count vectorizer of my entire data set, right? Now again, I don't know why this is still running, so let it run. Meanwhile, let's proceed to the next section also. We'll prepare the code again. We'll just run it when the code is running, when the code is ready for the other previous section. Cool. So we'll prepare for TF-IDF also. So we have already prepared the code for my count vectorizer. So let's do it for TF-IDF again. We can do it for TF-IDF also. So again, the same thing. Logic is same. So you know what is TF-IDF, right? TF-IDF is not available directly, so you have to call it from sklearn. Okay, so it's not available directly, so you have to call from I think sklearn sklearn dot I don't remember. I think it's in feature extraction. I think so. Let's check. So I think feature underscore extraction. That should be the one, and I'm gonna import TF IDF transformer. So I think that should be the TF IDF. I think that should be capital T. I don't know. So transfer more. Okay. So anyway, okay. It looks like this is an crazy, wonderful. Finally, okay. Now let's run the code and then we'll come back to this. Cool. So let's see that count vectorizer now. Okay. What's the error? So what's the error? What's the error? Okay. What's the error? Okay, list object has no attribute lower. What's the error? Why? Okay, so this looks fine to me. Why? Okay, so this is messages is fine. I'm gonna fit it over my data set. So Vectorizer is also fine. Spelling is good. And the data set, I'm gonna call it over message. So okay, interesting. So this data set is actually not converted. So now look at the data set, guys. Okay, so now you have the list of words, right? Yeah. Okay, so now you have to actually convert this list back to my sentences again. Okay, interesting. We missed one point here. So we have to again create this data sets. Okay, cool. So I got the error, right? So I'm gonna convert this message back to my sentences. So basically I'm gonna join this again to my sentences. So let's do that. So I'm gonna apply what I'm gonna do. So I'm just gonna do a join. So we can just do it over lambda, right? So we can do that. So just do here. So we can do aggregate of lambda, and then we can call it over join function. So we can do that. So that's gonna be dot join. And what I'm gonna join? So I'm gonna join the string over map, right? So I'm gonna call my map on top of this, and I'm gonna make my string and where my x comes. This looks fine to me. Let's run this. This should be fine, yeah. And then I have my data set here. Let's look at this data set. This should be fine now. Yeah. Did I miss anything? I think I joined it. No. No. I think this is wrong. Okay, let's check this for now. Okay. Only content empty vocabulary. Yep. So I think I did a mistake here. Now the problem is I need to run this again. Oh my god, which I don't want to do. Okay, so what we'll do is we will just run the data set. So what I'm going to do is I'm going to call this data set. I'm not going to run this function, so I'll just do it quickly. Okay, so that is the problem here. Okay, so this will take time. So I'm just going to call it again, the data set. Okay, so I'm just going to do only the necessary things. Okay, I did a small mistake. Okay, so I have the labels here, and then I have what this all is fine. I'm going to apply the length. I'm going to have the data and the length. This is fine. This is fine. Validation is all not needed now. So I have the processing function also there with me, so I'm not going to call the processing again. Okay, and then I'm gonna call my head, looks like. Cool. So let's proceed with this again. It's fine. Oh, fine. I mean, you already know the concept, so I'm not gonna waste any time here. Yeah, so I'm not gonna waste time here, so it's fine. So there is a very minor error, so because it will take time again to call this function and all that, so I'm not gonna do that. Okay, so what? So what just happened? So data set message. What's the error? So none type object has no length. Why? So why this? Okay, my bad. So it should be vocabulary underscore maybe. Yeah, cool. So so I have total of 8672 words. So again, there might be some issue because we are not removing the stop words and all that, right? So might be my model performance might not be that great. So that's fine. But anyway, let's proceed and let's try to see, because you already know the concept, right? So that's fine. So I want to show you some other things so we can proceed with that. So now for this part, we have already done this, right? So I'm just gonna uncomment this for now. I don't want it to run again. So I'm just gonna call one of the messages here. So from my message, I'm gonna call the fifth message, for example. Okay. Now I'm gonna transform this, and let's see how does it look. So now the message got converted into zeros and ones. Can you see this? So basically, my individual messages is part of my this column. So the first word was the part of my 1207th column. So the second was 2712th column. So likewise, I'm giving all the ones here, the count of my words, right? So this fourth word got repeated twice in this. So it's in the index 3781. So this is how the entire bag of words converted looks like. Okay, and this is how my the shape of my bag of words, because ultimately I have one document. So this is one document, one row, and I have 8672 columns in this, right? So this is how my individual row shape looks like. And now the same thing has to be applied to my entire data set, right? So now it has to be applied to my entire data set. So now let's look at this. So I'm going to apply the same thing of my entire data set. So I had 5572 rows. So all of my documents, so into here, document means my rows basically. Okay. So all of my documents are now converted into my bag of words. So where the number of columns are 8672, basically 8672 unique words are there. Okay. And that got spread into my individual columns. So now I have 8672 columns. So 8672 individual columns with unique words available in my documents. Okay, and then each of these documents columns will be having the count of my occurrences for each document, which is basically my row. Okay, got it? So this is how my count vectorizer works. Okay, so now okay, so let me just import feature extraction होना चाहिए. Okay, feature extraction, import EF IDF है क्या इसमें? I don't remember that, or maybe feature dot text import It should be TF. Yeah, it is here. So TF IDF. What I want, I think I want the transformer here, right? So I need to first transform and then vectorize. Yeah, so I think I need to first transform that. Let's import. Oh my god. So TF I need to transport that so I'm going to import the TF IDF transformer from here. Okay, the same logic, right? So again, the logic is same here. I'm not going to show it to you all the things, so I'm just going to call this for now. Okay, this is going to be my vectorizer. Okay, so basically this is my vectorizer, bag of word vectorizer, and I'm going to call my EF here. So this would be my word. So here I have the function TF-IDF transformer. So this is basically my function name. So TF-IDF transformer, and this is a function, so I'm not renaming it again. So I have to provide the parentheses here, and I'm gonna fit my message bag of words. Okay, so this is again this is fine. I'm gonna pass it over the messages back of words. So in fact, I can actually pass it over the actual bag of words where I've transformed based on the count vectorizer also. So what I can do is I can do on top of my ensemble model. So what I can do is I can actually use the existing bag of words, right? So I can use the existing bag of words, which is like this. Okay, I'm gonna pass it over here directly. So let's do that. So in fact, I can just use the existing bag of words which I have. So that is also possible. Why not? Cool. So let's call this. So yeah, so that ran fine. And now what we can do is we can again check any of my transformer. So on top of this, so I've created my vectorizer here. So now I'm just going to call the same data set, for example, here. So check the same thing here. Okay, so I'm just going to call it my vectorizer, right? So just okay, no, I've converted into data, right? So I'm just going to be the call the bag of words uh, 4. So maybe I'm going to call it on top of my say so okay, so I can do it on top of my message 5. So basically this bag of words 5. So I'm going to call it over my bag of words 5, which I've created. Okay, so let's check it how the bag of words 5, which I've already created for count, looks like for TF-IDF, right? So we can always do that. So let me just I think it's fine, we can do that, right? Yeah, so this is this. So what I'm trying to do here is from the same TF-IDF vectorizer which I've created, so TF-IDF transformer which I have, right? So on this TF-IDF transformer, I'm trying to fit the data which I've already created, the bag of words, and I'm trying to pass the same message which I have earlier, right? And trying to see how this transformer looks like. So basically here, I'm going to use the same bag of words 5 here. So I'm just going to use this. So instead of this transform, I'm going to use this one. So this is where my transformer is, right? So instead of my bag of words vectorizer from the original one, I'm going to pass it here. Okay. And in this, I'm going to check my transform function of bag of words. Here I'm going to pass 5. So I think this is what I've created here, right? So bag of words 5. So I'm going to pass it here. So this is what I'm going to do here, and this is what where I'll be checking my actual I'm going to name it as say TF IDF 5 here. Now look at this. So I have this. Now we can always check this TF IDF now. So I'm going to print this TF IDF. So now can you see this? The same transformation which I had earlier in terms of 1 and 2s and all that you saw, right? So now we have some decimal values, the float values, because it's more of a logarithmic values. So where the most occurred values will be penalized and all that. So this is how the sparse matrix looks like of my TF-IDF vectorizer, right? So the same thing got converted from 1s and 2s where the counts are available to the float values, right? So where the priorities are given. So the lesser occurred words will be given more priority, and the more occurred words will be given lesser priority. So this is how the TF-IDF is doing the calculation internally. Cool. So I have my TF-IDF vectorizer done. So now I'm gonna transform it into my entire data. So this is just to check purpose, right? But again, I have to transform it onto my entire data set. So I'm just going to create, say, a message. So here again, for my entire set, I'm going to use the same thing. Okay, so here on the same part, I'm going to use this. So for this message bag of words, I'm going to do message tf idf. Okay, my this vectorizer, I'm going to call my bag of words this one. So this is my new transformer. This is what I have to use, right? I've just created that, and I have to use this, and I'm going to transform it my entire messages ka bag of words. So where my, so I'm going to pass my entire message bag of words on top of this. Cool. That's what we're doing. So we have this. So we have the messages. I can always check the shape also of this. So print dot shape. Again, there should be exactly the same. So because the logic is still the same, so this, the number of rows and the number of columns will remain the same. It's just like my values of this TF-IDF will be changing. So I'm just going to show it to you. So how the data looks like. So if you're going to just see the data, so yes, it's a sparse matrix. So anyway, so I'm just not going to print it. So anyway, so we have the information available here, the number of documents 5572, basically my number of rows, and now I have the number of columns as well. So 8672, basically number of unique words I have here. Cool. So this is how my vectorization also. It's basically transformer is done, right? Now I can actually do the vectorizer also. I can now I can have the actual vectorizer also being done on top of this. So I can also add the transformer and the stop words also on top of that. So so now we can actually do, so the next step would be here to transform the data into the final, to create the final data set. So before the machine learning model, this is where I'm going to create my final data set. Okay, so we have just used a transform here, and I'm going to use the vectorizer. So I'm going to create the final vectorizer data set. So here from the same library, I'm going to import the vectorizer. I think I imported it somewhere here. Where did it go? Right, so I have this. I'm going to call this, and this is where I have my final set. So I'm going to call it TF-IDF transformer ki jagah pe I'll be calling the TF-IDF vectorizer, right? So from this vectorizer, now what I'm trying to do is I'm trying to add the features. So basically I'm trying to create the data sets where my features will be available. Okay, so this is where my vector will be. So I'm just creating a vector here. Vector would be this TF-IDF vectorizer. I'm going to call it here, and then on top of this, okay, my bad, I will just copy this. Yeah, so this will come here. So on top of this, see what all I can add. So basically on top of this, there are a lot of functions basically. So basically I can add the encodings, I can add the stop words and all that. So basically what all I need. So I'm just going to use the basic stop words. So I'm going to use the so don't count the stop words basically. So I'm going to add the function of stop words here. It has an argument of stop words. Stop words I can pass a language. I can use the language English. So what it does, it's going to ignore the stop words by default. Okay, so this is the reason why I did not spend much time of doing the encoding before. So it has this TF-IDF vectorizer has internal features basically. So now on this vectorizer, I'm going to call the features. So basically this is now where I'll be creating features. Okay, so now from this features, I'm going to fit the model. So I'm going to fit the vec.fit where my actual messages will be given. So sorry, not fit. So fit underscore transform should be there. Transform. Okay. It's twice. Transform. So I'm going to transform my actual entire data set. So this is where my data set and the message. So that's my set, right? Data set underscore message. Yeah. So now here from this, I'm creating the feature set, basically my number of columns, my individual columns for my data set. Okay, so this is the whole objective here. So this is not required. This is done, right? And then from this feature set, I can just check the basically features shape. So I have features dot shape. Okay, so I can always check this. And also, as always, we can also check the length of my vocabularies. So all of my individual events. So we can, or just leave it for now. Not required. So just this should be fine. Now I'm gonna run this. Right. So now I've created the my features, basically my individual columns for my data set. And here in this case, you can see again the logic is still the same. So my number of rows remain the same, 5572. But since I've added a feature of my stop words, it has by default reduced the number of columns. It has removed my unwanted features, which is not part of my, which is more of a stop words for me. Sriniti, okay, so hidden Marco model, yeah, obviously we can do that. Yeah, I can take this as a more of my feedback or the expectation, but it's not part of our today's agenda. But I can definitely explain that. So I'll try to add this in one of my contents in the upcoming lectures. I'll do that. Okay. Dhruv, I'm not sure what's the issue. Might be some network lag, but looks fine to me at my end. So it's speed is fine. Okay. Okay. So basically now I have actually created the final data set which can be used on top of my the actual split. So on top of my actual feature set, the data set, right? Up for the model building process. So now my data set is ready. Okay. And now the next thing which comes is my machine learning model. Okay. So building up my machine learning model. So machine learning model को build करने के लिए सबसे पहला step होता है we create a train test. Okay, so train test क्या होता है? So we are creating suppose I have say 100 rows, right? So if I have say 100 rows are there for me, okay. So I'm gonna give, for example, say 80 rows for training, and I'm gonna give 20 rows for test. Okay, so basically 80 rows के हिसाब से मैं उसको train करूँगा, and then I'm gonna score it, test it based on the remaining 20 rows. Okay, so that's the idea of say train test bed, for example, and this ratio could be anything depending on again on your standard is 70-30 or 80-20. We have something called as validation set also. So we keep a separate set altogether. This for validation. That's a separate story. But for now, what we'll do is we'll just use the train test split, the module which we have. Okay, and we use a test size or something like that. So now here let's do that. So what we can do, so we have uh, we have created the TF-IDF now. So let's use this messages of TF-IDF. So we're gonna use this TF-IDF messages. Okay. So we're gonna call this for the model purpose. Cool. So now what we can do is in the train test, so basically we have the X and the Y's. So where the Y would be my class, okay, so by basically my label, and X would be my feature set. Cool. So feature is basically my number of features which I've created from the TF-IDF vectorizer here, okay. So, and for the train test, so it will be for Y, Y of both train and test, and definitely X of train and test. Okay, so this is how it is. So likewise, when I'm gonna do this train test, right? So this is how it becomes. So it's gonna create y underscore say. Okay, so I have say message underscore train. I'm gonna make it more clearer for people, and then I'm gonna write say message message underscore test, and then I'll be having say what label. It's going to be label underscore train, and then it'll be having label underscore test. Okay, so this is what the split will be giving me, the train test split. The four things will be given here from the train test split. So this is where my train test split would come. So I have the train test split, and in this I'm going to pass my TF-IDF created vector. So I have my vector defined. So I have my TF-IDF message, and on this I'm gonna pass my label, so which is gonna be my data set of label for my Y, and then I'll be having my test size. So I'll be giving my test size as say 0.2. So basically 80-20 split. This is what I'm gonna do. Okay, so I'll be having the train test defined. So now I'll be having all the train test given already. Okay. So we can always check the shape of my train and all that. So we can always check if this is done correctly. So print dot shape, and then we can always give dot test, right? So I have these many rows split into two different sections, my train and test, right? So I have my train and test being defined. So I have my train and test available. So now the thing is, I have the data available now to train the model, right? So for the training purpose, we have to import certain algorithms, to be honest. So that's where my machine learning module, machine learning algo import will come. Okay, so import. So this is where I'm actually importing certain algorithms to run the model on, right? So I can import. So there are many algorithms. Again, don't ask me this question, what to choose when. It only comes with practice. There are certain prerequisites for certain algorithms. So I'm not going deep in any algorithms. I'm just trying to show you how you can implement any algorithm for now. Okay. So generally, text data works better on the knife based model. Okay, something called as knife based. So I'm gonna import the knife based model for now, and this is again available directly under my sklearn module. We have something called as knife, if I'm not underscore base. Yeah, so this is fine. I'm gonna import from knife base. I'm gonna import the multinom. No, this is the function already available. Okay, so here again I'm just gonna call a functionality called as a classification. So classification would be this multinomial knife based cuff function. Okay, again guys, the reason I'm showing you this is it's because the implementation is very easy. There's nothing fancy in the implementation part. I'll tell you, hardly 3 lines of code. Okay, so I did the train test split, right? Now I'm going to call this function the multinomial knife base, my function of my knife base module. And now here is where I'm going to create the application. So basically my spam filter module. Okay, I'm going to call this spam filter module. This is where I'm going to call my CLF. I'm going to fit it over what? My train. So here I'll be fitting it on my train. So here my train are my message underscore train, which is my X, and the Y is my label underscore train. Cool. This is how I'm going to do it. So this is very simple thing. Now the model has been trained. That's it. So this is what my module is. Now the model is trained. There's nothing which I just did, right? Now on top of this, I can just call a predict function. Okay. So now I just find a predict underscore train. So I'm just going to call on a prediction on this. Okay. So this, I'm going to call the same module. I think this does not get copied. So I'm going to call the training which I did. So I'm going to call it over here and then run the function predict. Okay. In this predict, I'll be again the same thing, message underscore train. So let's see, my predict train will come here. Okay, so I have the predict train being defined. So this is how my ham, spam, and all is coming. Okay, so my labels. So all the prediction is coming. So prediction is working fine now. Now I have the predictions in front of me, right? So I can always do now I can always check the evaluate how the predictions are for me, right? So always evaluation of my model. In this case, what I can do is there's something called as confusion matrix to check the performance of a model. So we can just print the classification reports actually. Okay, so again, I think I must have imported the metrics. So metrics, yeah, so metrics is there already. So under the metrics, we have something called as classification report. So if I just call the classification report on top of my training set, so basically my label train and my predict train. So I'm gonna check it how my actuals was and how I predicted. Predict train, yeah, it came right. So let's see the prediction report. Okay, let me print this. So this will be better if I print it. Cool. So can you see this? My precision is 97%, for ham, for spam is 100%. So my training performance is actually very good. So I just created a model on my training data set, right? Now likewise, I can actually do it for test also, right? So now I have my training, the testing done on my test. So I can also predict the actuals on my test also. So now instead of training, I can do it for test. So for this test, I'm going to pass the message of test, right? So now the prediction will be coming on test. So now in the same case, I can just print the same confusion matrix from my test also. So in this case, label underscore test and then predict underscore test, right? So this is also equally good. So I have 97% on precision on ham for the training, but I have 95% on precision. So equally good. So nothing major difference. So this is pretty good. So this is how it is, right? So did you just see? So machine learning is just this, only 3 lines of code, nothing fancy, guys. So do not get confused with the implementation part of your machine learning. Okay, it's all how you create your data, how you make your data. Okay, so this is a very simple data set, so very simple thing. So don't know much, not very much complexity involved here. But again, the life problem when you do in your business, right? So it's basically how you prepare your data. So your actual effort goes in your preparation of your data. So the machine learning model implementation is very easy. You just saw hardly 3, 4, maximum 10 lines of code, nothing fancy. So every time, whatever algorithm you build, like a random forest, decision tree, XGBoost, whatever algorithm, right, is hardly 10 lines of code, nothing fancy in that. So do not get confused by these, confusing terminologies of machine learning and all that. It's all how you analyze your data, how you prepare your data. Cool, making sense? So this is what I wanted to show you guys in terms of the live demo. I'm pretty much done. This is how the entire journey of a problem statement is, right? So we start from somewhere, we do the analysis, we see the data, look and get a look and feel of it. We clean it, we prepare it, then the model is being prepared, the final data set is prepared after the cleaning process, and then it's sent to the machine learning model, which actually built up a classifier or whatever logic is, right? So that's the entire journey of a problem statement, guys. Make sense? Anybody has any questions before we wrap up? So I'm pretty much done for the day. So this is what I wanted to cover for the live demo. Cool. So if you're good, then thank you so much. Thank you so much for being patient and listening to me on the live demo. So as always, if anybody has any other questions, so we can always take that. But we are good for now. So what we're going to do is we're going to wrap up the NLP with this, and we'll be coming back with some other set of interesting things in data science next month. I'll plan up the schedules. But we're going to meet again tomorrow, the same time, 10 p.m. But we'll be doing some of the problem questions from Lead Code. So we'll be doing some competitive programming questions, part of your interview process from Lead Code questions on Python. We're going to do that for tomorrow. Cool. Thank you so much, guys. See you tomorrow, same time, 10 p.m. Thank you so much. Bye-bye.